Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will try to implement some of the programs, example programs using the recursive concept. So the first one is calculating the sum of the digits of a 5-digit number using the recursive. So here what we will try to do it is in this one the program expression. The last digit of the number is obtained using percent. The rest of the number is obtained by dividing by 10. This process repeats until the number becomes 0. So when the number is 0, recursion stops. So recursive case is add the last digit to the sum of the digits of the remaining number. So now let's try to find it. So for this one, so what I will try to do it is, so here we are having the main program, right? So in this one, I will try to take int num and also the sum. Okay. So here I will try to do printf enter a 5-digit number. Okay, so one by one 5-digit number I will try to calculate it. So scanf %d ampersand num. So now if it is a 5-digit number means 1 2 3 4 5 means 5 plus 4 plus 3 plus 2 plus 1 like that, or otherwise 2 3 6 means 6 plus 3 plus 2 like that. I need to calculate it. So now here you can ensure that if it is a 5-digit number or something like that means, so we can write a condition like this. If the number is less than 10,000, if it is greater than 99,999 means then invalid input, you need to enter a 5-digit number. So now here, so we can return this one. So now I need to calculate the sum of these digits. So now here I will be calling the function. So here I will be calling like this. So recursive sum, so printf. So now here, so this is the recursive sum. Let's try to write the function declaration. So int sum of int. So this is the function declaration. So let's try to write the code here. Int sum of int n. Okay. So now in this one, if you try to see the output for this one, so let's try to write it. If n is equal to 0 means, then if n is equal to 0 means, then we can write then we can return the 0. Okay. Now if it is not equal to 0 means, then what I would be trying to do else means, in this else situation, in this else condition, return n mod 10. So it will return the last value plus r sum of n by 10. That's it. That's it. So this is a recursive function. Now if I try to execute this code, so it will ask you, okay, r sum, what it is saying, yeah, it is an r sum, recursive sum, right? So now if you try to, what is that it's saying again? Okay, so the declaration is missing. So if I try to say, it is enter 5-digit number, okay, 3 5 6 8 9. If I press enter, so the sum of the digit is 31. So like this you will be able to calculate the recursive using the 5-digit number. So sum of the 5-digit number we can calculate it. The next program what I am trying to do is prime factors of a number. So now start with the smallest prime number. So we will be starting with the smallest prime number 2. If it divides the number, print it and divide by the number by it, otherwise move to the next number. So the function keeps dividing and reducing the number while printing the factors until the number becomes 1. So here for this one what I will be trying to do it is, so this one let's try to remove this entire code. Okay. So in this int, I will remove this declaration also. So this is the return 0. Okay. So now let's implement the code. So now first we will be asking the int number. We will be asking the number. So now here we will be scanning. We will be asking how many numbers from 5 means 5 4 3 2 1 like this. We will go on calculate. So if number is less than 1 means, then we can print that number should be greater than, like this, number should be greater than 1. We should print it like this. Okay. So now what we will be trying to do here, so now we will be calculating the value. So that is nothing but printf prime factors are, and we will be calling the factorize. So now we will be calling the factorize. So let's declare this one. So here void now here we will be having the factorize thing, void factorize of int comma int. Okay. Now here let's implement the implementation, void factorize of int n comma int I. So this is the method for this one. So now let's try to implement the method for this one. So first one is if n is equal to 1 means just we will be returning it. So that means if n is equal to 1 means just return, that's it. Okay, now we can write a condition, if else condition. So you people already know about that one, the code. So if n mod I is equal to 0 means then we will be printing, we will be calling the factors again. So continue with by reducing the number, or otherwise we will try the next potential number. So now let's try to see the example for this one. So for example, if I try to write 5 means then the prime factors are only 5. So for example, let's try to see again. Let's try to see 10. So now the prime factors are 2 and 5 for this one. So like this you will be able to calculate one by one. So hope you understood about this one. So by reducing this one we will be able to continue it. Now next one what I want to show is the Fibonacci sequence. So how we can calculate the Fibonacci sequence for this one. So let's try to see the Fibonacci sequence for this. Okay, so I will be doing the return 0 for this one. So I have already the code with me. So just I will try to write it and show you. So now here let's say that in term, so here what I will be trying to do, calculate the Fibonacci series like n minus 1 plus n minus 2 recursively. So if n is 0 or 1 means so we will return the n value. So here I will be taking the into terms is equal to 45. So now here we are trying to print the Fibonacci sequence for this one. Now I will be looping over each one. So for loop, okay, and here I will be calculating the Fibonacci series for this one, Fibonacci of I. Print each Fibonacci number. So now let's try to print like this and remove this one. So now fine. Now let's try to implement the Fibonacci series for this one. So I already have the code with me. So at the top you can mention it directly instead of having the declaration. So you can directly have this one. Now like this. So int Fibonacci int of n. If n is equal to 0 means we are writing 0. If n is equal to 1 means we are writing 1. Or otherwise Fibonacci of n minus 1 plus n minus 2. So we are trying to calculate like this. Now if you try to run this code, so now here we will be able to see the Fibonacci series. So in this way we will be able to calculate the Fibonacci series using the recursion. So these are all the different examples which we will be trying to do it. So now recursive functions breaks a problem into a smaller subproblems. Each problem requires a base case to stop the recursion. These programs which I have demonstrated to you, so you practice it, the beginners guys who are in the programming language, so that you people can able to have a strong knowledge in the programming side, something like that. So this recursion simplifies the problems by focusing only on the current step and delegating the rest to itself. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.